Hi all. Good morning. Hope you all are doing good. So now that I have seen in the last videos, we have seen like how to create Azure account, how to create Databricks storage. We have explored what is blob storage and what is ADLS into storage, right? So now it's time to learn what is Databricks cluster. So as a part of this video, we are going to see what is Databricks. We'll try to understand what is Databricks first of all, and we'll try to create one Databricks workspace, right? We'll see how to create it step by step. Then we'll create one compute engine and we'll attach with that workspace, and we'll see step by step how to create that as well. Then we'll be creating one notebook where we'll be writing our Spark code, right? Then we'll be running and verifying whether that notebook is working fine or not before we start uh, learning any PySpark codes, right? So these are the things that we need to be ready with us before we start writing any PySpark code in the database cluster, right? So at the end of the session, like we'll be having a fully functional database cluster. We'll be creating notebook, and that notebook will will be moving it ahead with doing practicas, whatever we can for PySpark, right? So this is what we are all going to do with this video. Now that before we go to start implementing the practical, right? We just need to understand what is Databricks. So let's see, what is Databricks first of all, right? Databricks is a cloud-based platform built on Apache Spark by the original creator of Apache Spark, right? It simplifies big data processing by managing the infrastructure, cluster, and scalability for us, right? So this gives a cloud platform where we can practice our Databricks, PySpark programs, right? So now that we know what is Databricks, we need to know, okay, who created this Databricks first of all, right? So the Databricks is created in 2013. That is being created by the original developers of Apache Spark, right? So now that we are learning this Databricks on top of Azure, whether it is really a product of Microsoft, no, right? So it is a product of Databricks company. However, Microsoft has partnered with Databricks to offer Azure Databricks, which is a fully managed service for Microsoft Azure, right? So now that we know it is not from Azure, it's a completely separate product of Databricks company. Okay, now since we are going to use with Databricks, Microsoft Azure platform, Azure platform, right? So it is seamlessly providing integration with all the storage, Azure Data Factory, Power BI, and all that integration can be done easily with the Databricks. That is also one of the main reasons why it is useful when we are going with Azure, right? So when it comes to the cluster, right, whether it is really available with only Azure, Azure cloud providing platform, or it is available with others. No, it is available with others as well, right? So Azure, when it is there with Azure, we call it as Azure Databricks. In AWS, it is Databricks on AWS and Databricks on Google Cloud Platform when it comes to GCP, right? So now that we are trying to learn this, we should understand why this Databricks is so popular, right? So it is popular because it is supporting many other languages like you see Python, SQL, Scala, Java, and R. All this language is being supported by this Databricks, right? Which is optimized for large scale data processing and widely adopted by enterprises for data engineering, analytics, and AI workloads, right? So it is mainly focusing on the data engineering, analytics, and AI workloads. So we know now why it is popular. So what, like how this is being used by a real data engineer, right? So generally data engineers use this database platform to build ETL pipelines, product process large scale data sufficiently, read and data read and write data from cloud storage, perform batch and streaming operation, right? So to automate workflows and scheduling jobs, and to create reliable data pipelines using data lake, right? So all these data engineers use, because of all this purpose, to fulfill their purpose, right? They are using this Databricks platform. Now that we are going to learn it, we should know why we are learning it, right? So Databricks is one of the industry's most widely used platform for Spark-based data engineering, right? So it provides an easy and scalable environment to develop, test, and deploy PySpark applications. So it gives the platform to develop, deploy, and test. Everything we can do it in the one platform, right? So for that reason, we are learning. So now that we have one background of okay, what is Databricks and why we are using it, now it's time to see like why we are, I mean, what we are going to practice as a part of this video, right? So now that we have seen it, right? So previously in one video we have seen how to create one Azure portal. In that the next video that we have seen how to create one Azure storage, and we have explored blob storage and ADLS Gen 2 storage. Now it's time to create a Databricks cluster, and we'll be exploring the notebook. So this is what we are focusing on now. We are going to create the Databricks cluster, right? So what specifically we'll be learning in this one, right? So as we have know, we have this account and we have this tenant ID available with us. Subscription ID by default we have got it. A resource group we have created in the last class while creating the storage, and we have created the storage as well, right? So now we are going to create. We are going to mainly focus on what I mean. We are going to create the Databricks cluster first. Then we'll be attaching one compute engine to that particular cluster that we are going to create. Then we'll create one notebook and we'll explore, okay, it is providing us the runnable environment for the Spark program or not. And we'll be testing the notebook so that we'll be verifying, okay, everything that we want to run going forward will be readily available with us with this particular environment, right? So now we are going to implement this. So before going to implement that, I'll just show you one thing. I have created one document where we can have all those configuration related details. I have mentioned it here that we can go through it. This above one, it's created for creating the Databricks workspace, and the below one, we have it created it for the compute engine, right? So it has all this configuration details, what we are going to set it while we are doing the practical. Okay. Now after doing the practical, we will be having understanding of okay, what is compute and all that will be seeing while doing the practical. And after everything environment is set up, right, we'll be testing okay, whether this database cluster that we have created, whether it is supporting Python, SQL, Scala, or R, and all that it is supporting or not, that we'll test it. Okay, then we'll be coming to this line of code, the Spark session, right? So by default, generally in Databricks, we are getting the Spark session available, readily available with us. We need not to write this line of code to create the Spark session, but still we need to understand, okay, how a Spark session is created when we are running it with the Spark submit and all that, right? So we need to understand this one. So without further delay, let's start creating the Databricks cluster now. So we are going to create the Databricks cluster first, then we'll come to this one. We'll go step by step. So let's go to this Google. We'll log into the Azure portal. Okay. So there we'll explore all this, how we can see to create step by step. So now we are going to look for one service Databricks, right? So look for Databricks. We'll see how to create it now, right? Yes. Now let's click on create. Okay, so when we come to this page, right, it asks for few configuration detail based on what we are going to configure our workspace, right? So subscription AO, you know, by default we get it when we are creating any Azure account. What resource group, right? If you remember, we have created one resource group with the name Azure Dev Data Engineering, right? We are going to choose that resource group because we have the storage account configured in this resource group. That's why we are choosing this one, so that when we are going to integrate this data, our storage and our Databricks, right, it will be easy and we'll get good performance, right? So we are going to choose the same resource group which we have created during the creation of our storage, right? So now we can give one name of this workspace. We can give any name, but that should not be existing throughout the Azure platform, right? It should be unique across the platform, right? So let's say cluster Dev Database 40 minutes run. Any name we can give it, but it not be existing uh, uh, in the platform, right? So now, what is region, right? We know what already what is region. So what it does exactly when we choose the region, right? We are going to go with South India because we have deployed our resource group and storage on the South India region to get better performance and low latency, right? We are going to choose the same region where our Databricks cluster will be hosted, right? We are going to go with the same option. We are not going to change it. So we'll be having multiple options. I mean, multiple regions, but we are going with South India because of we have the storage in the same region, right? Now, so what is pricing tier, right? So based on the price rate, we are going to get the feature and the access controls, right? So we are going to go with the premium so that we'll get proper best features and the access control will get it, right? So we're going to choose these options, right? That is for pricing. And why we are seeing South India serverless workspace are not supported in the region South India. So since it is by automatically serverless, it is clicked. That's why we are getting this error. But we are not going with the serverless workspace type. We are going to go with the hybrid type, right? So once you click on the hybrid type, that error is not coming, right? So when you come to workspace type, we should understand, okay, what is a workspace type, right? So serverless. Whenever we are choosing for any uh, uh, serverless workspace type, right? It is the Azure is going to take care of the storage and compute. We are not going to be involved in that. But when we are choosing hybrid, we ourselves we are going to take the storage separately and our compute separately, and we'll be configuring the next step, right? We are going to configure a cluster. That's why we are choosing the hybrid model. If you are going to go with the serverless, everything storage and the compute is going to be taken care by Azure. But here we will be taking care of storage and compute, right? So we'll just review and create it now. It's just validating. Yeah. So sometimes what happens, while even if it validates successfully, while deploying, if it finds the similar name is existing in the similar workspace name is existing in the platform, right? It will throw error. But now that since it is validated successfully, so I think we are good to proceed on this one. We are not doing any changes. We have just given the workspace name, Azure subscription. Here by default, we have got it. We have selected this resource group and region, South India region, because we have the storage account being placed there. And pricing tier, we have chosen premium, and workspace type, we have chosen hybrid. This is the things that we have chosen in the previous form, right? So now I am going to create. So what it is going to do is in the South India region, right? It is going to deploy this particular uh, Databricks workspace. So it will take a couple of minutes, right? This deployment is still in progress, right? We need to wait for some time. Maybe it takes 3-4 minutes based on the resources availability and network speed and all that, right? So we'll wait. As I was telling, right? Actually, it failed. So what I have to do is I just rename the cluster name and I have followed the same step. So now this new name cluster got deployed, right? So let's go there. So now we are in the home page of this cluster dev database test. Only just I have changed the name and followed the same step and it got deployed. And we are just going to launch that workspace, right? So let's close all this. Launch the workspace. It's going to launch. And in this workspace, as we have discussed, right, we are going to attach one compute. So we'll just quickly see, okay, where exactly we are in now. So we have created this cluster. Now we are going to, I mean, Databricks Workspace. We are just going to create this compute now. So let's do that. So I'm just going to go to compute. Okay. Hit on create compute. Okay. Now, when we come to compute, right, it will also ask few details to fill before we proceed, right? So now we can give any compute name. So let's give any compute name, any name that we can give. Okay, but that should not be an existing one. And what does it, this is the compute name that we have given, and now we are going to see what is policy unrestricted, right? So whenever we are choosing this unrestricted, right, it is for any user who is having access to this particular workspace, right? They will be able to, I mean, this compute, right? They will be able to edit any do any changes. But when I mean, we are not restricting anything. Like whoever has access to this compute, they will be do any operation on this particular compute. So that is the main purpose of this policy, right? So this machine learning, like based on performance, right, we are going to see like machine learning, we are not going to do anything, right? So we are not clicking anything. And the default Databricks runtime that it's set is like we are going to choose that one only because that is most stable version now. So it is 7.3 and Spark version 4, right? So we're just going to go ahead with that. We are not going to change that. And photon acceleration. What is photon acceleration, right? So it's a native SQL run engine, right? Which which helps Databricks to perform good. It's a native photon acceleration engine. Okay, so it is by default set to yes to give better performance. So we're not going to touch this one, and we are going to create a single node cluster because we are going to uh, practice with the single node cluster, right? So we are just going to have the single node cluster enabled option, and we have see standard D4 DS V5 and 16 GB memory. We are going to choose a virtual machine, which is by default it does enable 16 GB RAM and 4 cores. What does this 4 core means, right? Whenever we are running any Spark programs, right? For each core, it is going to run one task. That's so that parallelly 4 tasks can run with this virtual machine. So we are not going to do any complex operation for now on this one, right? So that's why we are going to the basic preferred node type we are going with, right? And the runtime termination after 120 minutes. So what I are going to, let's give 40 minutes, right? So after 40 minutes, this compute engine is going to automatically get stopped, where we will save our billing, right? Unnecessarily when we are not running anything in PySpark, why we need to be charged for that, right? So the less time based on your need, right? You are going to give the timing. So we are just giving 40 minutes so that whenever we're practicing each time within 5-10 minutes, it is not going to get disconnected, right? So for that reason, I'm just going here 40 minutes. Any based on your preference, you can give this timing. Okay, we're not going to touch this tags and all, leave it. And in the advanced option, right, we need to choose manual, and we are just going to go with the single user mode because we are the only user that we are creating it, right? So we are not going to go with the office environment, but since we are single user, and why we are choosing this one is, right, if you are not going with the single user, right, we are going to get some issues while trying to run any RDD programs, right? So we'll get some issues there, and the Spark system will not be properly set here if you are not choosing. So this is a very important thing when we are choosing this runtime version 7.3 LTS, right? But if you're going with older versions, we need not to do any settings change over for this advanced setting, right? But when we are going with this one, right, because we are going to practice RDD, data frame, and Spark SQL and all that, right? So for that, we need to be, if you're going with this latest version, we should be enabling this as a single user or else we'll get issues. So remember this one, this is important. If you, which person you are choosing, based on that it is going to behave the compute, right? So based on that you choose it. So now since you are going with the latest version, we are going to go with a single user. Now we are going to create the compute, right? So you see we have given one compute name, then unrestricted policy we are going ahead with, we have chosen this um, latest version, that is stable version, which is Spark 4.0, and we are going ahead with the preferred node type as 16 GB memory and 4 cores, and we are letting it get terminated automatically if your cluster is not being used for 40 minutes, and we are setting it as a dedicated single user computer, right? So now let's hit on create. I'm just going to create it. So it will also start getting deployed. You see, it is deploying now. So it is also going to take around 5 to 10 minutes. Sometime it takes more than 10 minutes as well. So no need to be worrying on that. So have patience, wait for some time, it will get deployed automatically. Okay. So we'll just So, all right. Now that I told, right, it is going to take around 10 minutes. It took now 15 minutes. So we need to be having patience so that we can see it, right? So it is created. Now let's go to the compute, right? We can see it being active, right? If you want to stop it, so we can get that, okay, this is the runtime that we have chosen, 16 GB RAM, 4 cores, uh, and source UI data engineer. And if you want to stop this, terminate this in compute engine, right, we can do it from here. Now that, see, we have created the Databricks cluster here, and we have created a compute. Okay, and we have attached this compute to that. Like while creating only, we have done this compute inside this workspace, right? So it is attached to that. So if you see your diagram that which you are checking, right? So we have done with these two steps. Like we have created a Databricks workspace and we have created a compute engine, right? Now we are going to explore, okay, what is a notebook and how we can start practicing over there, right? So let's go there. So here is the workspace. Let's open it in a new tab. I clicked on this one and control and click on this one. It's going to open a new tab. So this is the home page for this workspace where we're going to start practicing, right? So let's expand this one. Let's go to the users. Okay, this is our user ID, right? Inside that, we'll create one notebook, right? Create a notebook here. So we are inside the notebook now, and we just wanted to see, right? Now that if you go to the diagram again, right, we have created this notebook. Now we are going to try some PySpark and all those language, Scala, R, and all that code to test this notebook, whether this Databricks cluster is working perfectly fine or not. So now I'm just going to type Spark and I'm just going to hit enter, right? It is going to attach that compute engine, allow, attach and run, right? So it's going to run since it is already active, right? It is going to give us the details of the Spark session, right? Yeah, you see, here is the UI that we can explore. That is not we are going to explore it now. We'll be exploring it later. Okay, all that we'll be exploring later. This is our version of Spark that we have installed, right? And this is since you have taken single node cluster, right? We are getting it local and 4 core, right? Four tasks can run in parallel, and this is Databricks here. So now that we have seen, like once we generally in other platforms, like if you are practicing in any IDE like Eclipse and Python and all that, right? If you it is not readily available with the um, environment, right? But when we are working with PySpark, this is readily available with us, and we have seen it, right? So Spark is properly installed and it is working properly now. Since we discussed initially, right, it is going to support Python language, SQL, Scala, and R, all those languages it is going to support. We're just going to test, okay, whether those are really, working fine or not, right? So let's go here. We have this code handy, just not to waste time and all that. I have prepared this document. We're just going to run all this and see, okay, it is running fine or not. That way we will confirm, okay, this cluster is working fine, right? So now we have seen Spark, right? Now I'm just going to run Spark version. We're just going to see dot, right? The 4.0.0 Spark version we have installed. Now, since it is not giving us to create that Spark session, it is already available. Still, if you want to use the same line of code that you use when you're practicing with IDE and all that, still we can do that. So if I'm generally what it does is like it is not going to throw us any error because the main purpose of this get or create function is, right, it is just going to give us a Spark session if it is available. If it is not available, it will create a new one. Here Spark session is a class and builder is a object, and this is a function which we are generally we we try to create using uh, while we are using our ID and all that. But now since it is already available, we are not going to do that. But I'm just trying to show you, okay, even if you are creating the Spark session, it is not going to throw us any error. It is already available and it is not going to throw us any error, right? So we have seen this. So now we are just going to see, let's add one more code snippet and let's see whether Python is working or not, right? Python language. So X and Y you have taken, we are just doing a sum and printing it. This is a Python compatible syntax, right? So we are just trying to, since it is already Python chosen, we are not going to choose that. It's by default Python already chosen, so we're not going to choose. Let's run it. It should work fine. You see, hello Python, result is 50. So it is also working fine. Now I'm just going to see for the next one, right? So we're just going to check for Scala language, whether Scala language is supported or not on this data cluster, right? So now I'm just going to this is a syntactic figure of this Scala style programming, right? So we are taking a X bell where we are bell and we are just trying to do the sum. This is a syntactic figure of Scala. We need not to worry about that. My intention is just to show you, okay, whether it is supporting or not, right? So Scala. I'm choosing the Scala from this drop down. Now it is the error is gone, and if I run it, it should show me the output, right? Okay, so we are good on this one now. So let's go and see whether our language is being supported or not. You see, now I'm just going to give R, and the warnings are gone now. Let's run this one, and we should see. This is our language way of programming, right? Now R is also working. So now we'll just see whether our SQL is working or not, right? Which is our main intent to see going forward. Either you can keep like this, or if you're choosing it from the drop down also, it will come automatically. So anyway, it's fine. So now I'm just going to run it. You see, it is also running fine. So what we have seen, we have created this notebook, right? We have tested, okay, Spark session is being created properly or not. It is available. We have seen the Spark version. We have seen, okay, even if you're creating the Spark session using the get method also, it is not showing us any error. We have seen like Python code is also is being supported, Scala is supported, R language is also supported, and SQL is also supported. So all these are being supported. So now what we have seen so far is like if you go to the MS now, so we have created this cluster, we have created this compute, we have created a notebook, and we have verified all this language whether it is being supported or not. This is what exactly we tried to do as a part of this session. Okay, so I think you all got it right. So how we have done it, we just need to follow the same process that we have discussed. Do not miss any step in between. If you are missing while setting up the cluster and the compute, right, we might not see the similar result what we have seen just now. So just focus on whatever the steps that we have followed. Anyway, I'm going to share these documents, right? So you can follow this, whatever we have done, the same process that we have followed, and here it is just described properly. And compute is basically a runtime environment that we have created, right, which enables the Spark program to run in the compute. I'm not going to go in detail of this, what is compute and all now, because that is going to take some more time. But yeah, our intention here is to learn like how we set up the cluster, we start running the PySpark program, right? And we are done with that. And we have tested all this, right? We have tested all this, it is all working fine. And we have seen this as well, right? So hope you all are good with this. Alright, if we all are good, then I think we'll see you in the next video. Thank you.